Hello viewers, in today's class we are going to discuss another problem from logarithmic differentiation. And in this problem we have to find the derivative of y with respect to x at x is equal to 1. Right? So we have to differentiate this function y, which is equal to x cube times the square root of x plus 4 divided by x cube plus 1. Right? So here to find out the derivative of y with respect to x, we can make use of the quotient rule and then the product rule, right? But here we'll prefer the method of logarithmic differentiation by making use of the properties of logarithms. So let us see how we can find out the derivative of y with respect to x at x is equal to 1 using the concept of logarithms. So first we'll simplify this function with the help of logarithms. So let us take the natural log of both sides. So we'll get a log of, that is ln y is equal to a log of x cube times square root of x plus 4 divided by x cube plus 1, right? So what we have done here, we have taken the natural log of both sides. Now see, here we have x cube times the square root of x plus 4. So here we have the product of two functions. So what we will do, we'll make use of this property of log, that is log a over b is equal to a log of a minus the log of b. So we can now write log of y is equal to log of x cube times square root of x plus 4 minus a log of x cube plus 1, right? So this numerator can be treated as a, and the denominator x cube plus 1 may be treated as b. So now here we have x cube times square root of x plus 4, right? So here again we'll make use of one property of log, that is log a times b is equal to a log of a plus log of b. So now we can write log of y is equal to log of x cube. A can be treated as x cube and b can be treated as square root of x plus 4. So we have log of square root of x plus 4 minus, and we have log of x cube plus 1, right? Okay, now see, we can write these terms as log of x cube, and here we have log of x plus 4 raised to half, and here we have log of x cube plus 1, right? So let us make another important property of log, that is the power rule, that is log a raised to b is given by b times log of a. So in the first term, a is x and b is 3. So we have 3 times log of x, right? And here in the second term, a is x plus 4, b is 1 over 2. So we have half log of x plus 4 minus log of x cube plus 1, right? So viewers, with the help of logarithms, we have redefined this function like this. So now let us differentiate both sides with respect to x. So we have d by dx of log y, then we have d by dx of 3 times log of x, then d by dx of half log of x plus 4, then we have d by dx of log of x cube plus 1, right? Now 3 is a constant, we can take it outside, and the derivative of log x is 1 over x, and here again we have half constant, taking it outside the derivative, that is the operator d by dx. We have half. The derivative of log x plus 4 is simply 1 over x plus 4, right? So here we are using the derivative rule for log x, that is derivative of log x is 1 over x, right? And similarly the derivative of log x plus a is simply 1 over x plus a. And in this term, we have the derivative of log x cube plus 1 as 1 over x cube plus 1. And then by chain rule, the derivative of x cube plus 1 is equal to 3x square, right? The derivative of x cube is 3x square, and 1 being a constant, the derivative is 0. So here we have 3x square. And in the left hand side, we have the derivative of log y with respect to x. So the derivative of log y with respect to x is 1 over y, and then we have dy over dx by chain rule, right? So now taking this y to this side, we have dy over dx is equal to this term is now multiplied with this y here, and we have dy over dx is equal to y times 3 over x plus 1 over 2 times x plus 4 minus 3x square over x cube plus 1. So now we can replace this y by this expression. So dy over dx is now equal to x cube times the square root of x plus 4 divided by x cube plus 1 times 3 over x plus 1 over 2 times x plus 4, and then we have minus 3x square over x cube plus 1, right? So this is the derivative of y with respect to x. Now we have to find the derivative, that is dy over dx at x is equal to 1. So what we will do, will take x is equal to 1 in this expression. So here we have 1 cube is 1, then we have square root of x plus 4. So 1 plus 4 is 5, and 1 cube is 1, 1 plus 1 is 2, and then we have 3 over 1, then we have half, 1 plus 4 is 5, then we have 3 times 1 square is 1, 1 cube is 1, 1 plus 1 is 2, right? So let us simplify it. We have square root of 5 over 2. This is 3 plus 1 over 10. This is 3 over 2, right? So dy over dx at x is equal to 1 is now equal to this expression. So now let us simplify this expression. So we have dy over dx at x is equal to 1 as square root of 5 over 2. Here we have the LCM 10. Then we have here 30 plus 1 minus, that is minus 15, right? So this is root 5 over 2. This is 31 minus 15, that is 16 over 10. So this is 2 8s are 16, 2 5s are 10, 2 4s are 8. So this is 4 root 5 over 5, right? And if we rationalize it, then we can get 4 over square root of 5, right? So the derivative of y with respect to x at x is equal to 1 is equal to 4 times square root of 5 over 5, or 4 over square root of 5.